All right, we're in section 4.6 where we're going to use congruent triangles. So, over the last, 3 or 4 sections, we've been able to discover that there are different ways that um, we can we can prove that triangles are congruent. So it's either by angle, angle, side, angle, hypotenuse, leg, side, angle, side, or side, side, side congruency. So there may be given some situations where when we write out proofs, you are given some piece of information and then they're asking you to prove that either uh, the angles are congruent or sides are congruent in that way. And it doesn't directly tell you that those respected sides or respected angles are in fact congruent. But once you prove that that two sets of triangles are congruent using one of those theorems or postulates, we can then go about and say that, hey, those uh, angles or sides can be congruent by what is called corresponding parts of congruent triangles are congruent, or CPCTC. Now, here is a statement we need to make that you can't use CPCTC to prove that triangles are congruent. You can only use that statement once two sets of triangles are congruent. You can utilize corresponding parts of congruent triangles are congruent um, once you've established that two sets of triangles are in fact congruent. So what we have here is we have the statements and reasons for this particular example. So they're telling us that right off the bat, angle 1 is congruent to angle 2, and AB is congruent to DE. So what they're asking here is they want us to find that DC, which is right here, is congruent to AC, which is right here. So in this particular example, the first thing they're going to try to do is they're going to try to make out that triangle ABC and triangle DEC are congruent. All right, so we have to kind of, take steps and be able to prove that. So what they did here for step 2 was they said that, you know, angle 1 and ABC and angle 2 and DEC are a linear pair. Since they are a linear pair, we know that their sums are going to equal 180 degrees. Okay. All right. They said, A, B, and D was given. Because of this right here, we can set them equal to each other and subtract the two. We can then say that angle ABC is equal to angle DEC. So ABC, so like right here and right here equal to each other. So right now we have one side and one set of sides and one set of angles equal to each other. From here, we realize that angle DCE is congruent to angle ACB because of vertical angles. So now I have this here and this here. So now I have all all the necessary elements or all the necessary things that show that these two triangles are congruent. So it looks like it's going to be angle, angle, side. So I go over here and say, okay, I got triangle ABC is congruent to triangle DEC. Angle, angle, side is the proof for that. And now that we have a proof that these two triangles are in fact congruent, we can go to the proof and say, all right, well, DC is now congruent to AC because of corresponding parts of congruent triangles are in fact congruent. So that allows us um, to make that statement because the two triangles are congruent. By definition of congruent figures, more importantly, congruent triangles, that means that all of the corresponding sides are congruent and the corresponding angles are in fact congruent. So what we have here is we have a given where we're trying to say that ST, which we'll say is right here, ST is going to be congruent to RT, which is right there. And they're saying that SPR, which is right here, is congruent to RQT, which is right here. The statement that they want to make is they're trying to prove that PR, which is right there, is going to be congruent to QS, which is right there. So, looking at this, we have a set of congruent sides and a set of congruent angles. So right off the bat, we can go and write in the given. So ST is congruent to RT, and angle SPR is congruent to angle RQT. That is given. Second step here is I'm going to look at, well, the next thing here is I can tell that these two angles are vertical angles. So I can say that angle PTS is going to be congruent to angle QTR. And that's vertical angles. So right off the bat, I now can prove that those two triangles are congruent. So now I can say that triangle PTS is congruent to triangle QTR because of side, oh, it's here, we got angle, side, sorry, angle, side. So this is an angle, this is an angle, that's a side. So angle, side. So now that I have that statement um, out of the way, now we can go about and look at corresponding parts of congruent triangles are in fact congruent. So because that statement is there, I can now make a statement saying that line segment PT is congruent to line segment QT because I can now say that corresponding parts of congruent triangles are in fact congruent. So I can say here and here. So I have hash marks with PT, I have hash marks with TR, I have hash marks with QT, and now I have hash marks with um, ST. So with that being said, I can now make a statement saying that PT plus RT is going to be equal to PR, and I can say that QT plus ST is equal to QS because of those because of angle, not angle, these are segments, so this is a segment addition postulate. Just adding up those two angles together, so we'll just put in a different color. PT plus TR is PR, and QT plus like TS is QS. All right, now we can substitute in number 6. We can now say that PR is congruent to QS because we can substitute in PR and for QS because those are congruent line segments. PT and QT and RT and ST, they're both congruent. we can then say that these two are congruent by the definition of congruent segments. And that's what they want us to prove. PR is congruent to QS. All right, so we have this triangle here in question. So they're telling us that angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4. So I'm just writing those in. They want us to prove that A, B, D, so this triangle here, is going to be congruent to A, C, D, which is right here. All right. So let's write in the givens. So I know that angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4. So write in the given. All right, so next thing, I'm going to look at those two triangles. One's green, one is blue in this case. And I realize that line segment AD is shared. So I could say that AD is congruent to AD because of the reflexive property. So now I have one set of congruent sides and I have one set of congruent angles. So I need to either find another set of side or another set of angle to help me prove that those two triangles are congruent. But by looking at it right now, there's nothing that is given to us. There's nothing that I could easily identify where any angle or any side is going to be congruent. So now what we're going to do is I am going to try to attempt that this triangle here and this triangle here is congruent. So to do that, I can say in those two triangles below, I could say that DE is congruent to DE because of the reflexive property again. If you wanted to put this inside step 2 as well, because they're both the same property, that's fine as well. Other thing that I notice is that the intersection here with point D, angle 1, and whatever this angle is right here, and this angle is right here, they make up a linear pair. When they're a linear pair, we know that those angles are going to be sums of 180 degrees. So I can say, for step 4, I can say that angle 1 plus, and in this case specifically it'll be angle BDE will equal 180 degrees, and angle 2 plus angle CDE will also equal 180 degrees. And this is by definition of supplementary angles. Now, going into step 5, what I'm going to do is, since these are both problems that add up to 180 degrees, I'm going to set them equal to each other. Angle 1 plus angle BDE is going to be equal to angle 2 plus angle CDE, and that comes from the transitive property. Part 6, all I'm going to do is I'm going to substitute these two because I know that angle 1 and angle 2 equal to each other, so it doesn't matter which one you choose. I'm just going to choose to substitute both of them as angle 1. And I'm going to say angle 1 plus angle, whoops, angle BDE is equal to angle 1 plus angle CDE. And that's simply just from substitution. Next, I'm going to subtract angle 1 from both sides. So now I can say that angle BDE is equal to angle CDE. Or you can say it's congruent because of subtraction. All right, so now I know that this angle here is congruent and this angle here is congruent, and I know I have reflexive over here. So now I can say that for part 8, that triangle up on top, triangle BDE is congruent to triangle CDE. And I can show that that is congruent by angle, angle, side. So I got angle, angle, side. Why is showing that those two triangles are important? Well, now I can say that BD is congruent to DC. And that comes from corresponding parts of congruent triangles are congruent. Now that I have that statement in mind, now I can look at this triangle that's in green and blue and say, oh, I have a side, I have an angle, and I have a side. I have enough information to prove that triangle ABD is congruent to triangle ACD. So I can now say step 10 here is triangle ABD is congruent to triangle ACD. Now I can say it's through side, angle, side. And that is being able to use congruent triangles. Hope this helps. Until next time.